What's up? What's happening? What do you got there? Is that a sandwich? What? Good. Lesson 29, folks. Prime number. Solving literal equations. Oh, look, there's the binary way up in the corner. Solving literal equation, like literally, I'm going to solve an equation. Let's define that, okay? Define it. What are we doing when we're going to be solving literal equations? What is it that I'm looking for? What am I doing? A definition. Solving a two-variable equation in terms of one variable, or two variables or more, really, in terms of one of those variables. So it gives you you're like, okay, I still don't know what that means. All right, in the world of things like physics, chemistry, physical sciences, when you've got a formula that you plug numbers in, you don't always know the things like that would be over here on the right side, and then you plug these things in, you get this. This is Newton's second law of motion. Force equals mass times acceleration. Interesting thing is that that is not the way that Newton originally formatted that particular law. That particular law looked like this. Acceleration equals the ratio of the force on an object compared to its mass. Okay, so the second law is called the law of acceleration. So what I did right there is I solved this equation for acceleration in terms of force and mass. If I know the force and I know the mass, I can calculate the acceleration. Just as true as that top equation, if I wanted to find force in terms of mass and acceleration, that's what that would look like. I could even define this in terms of mass as being the ratio of an object's the force on an object compared to the acceleration, how much it's accelerating, which is kind of hard to visualize, but there you go. Moving the pieces around to solve for any one of the variables in an equation. Solving one thing in terms of something else. Now, we're going to start today with just two things. Typically, we'll have things like X and Y, or what we'll find more often is in the sciences, or things like conversion rates between one type of currency and another type of currency, or even going from feet to inches or something like that. I want to express one thing in terms of the other. Like, how big is an inch? Well, it's a 1/12 of a foot. How big is a foot? Well, it's 12 inches. I just did the same thing. I'm just moving from one side of the thing to the other. So let me give you one that's just real straightforward and just algebra, okay? Then we'll talk about the more practical ones, converting from one type of measurement into a different type of measurement. So I'll take a first example out of the reteaching. And yeah, 10b and 2a minus 4 equals 3b and a. Now, with a problem like this, one of the first things you have to be told is, which thing do I solve for? Am I going to solve for A or am I going to solve for B? And the job is the same as what we had before. Whichever one it is that you're going to solve for, that one needs to end up all alone on one side of the equal sign and everything else end up on the other. Except this time, that everything else on the other side, the solution, will include more variables. So if I solve for A, maybe A is on the left and everything else is on the right, including B terms. So let me do what we did before. This side's already simplified. Let me simplify this side. Oh, there's a whole lot I can do here. I got to move all the A's or all the B's all to one side. This particular one asks us to solve for B. I usually just circle the thing that I'm solving for so that I don't lose track of what my goal is. My goal is for this to say B equals, or something equals B. So I'm going to use that same rule that I used the last time and say, once I get down to it, I want to compare the sides. I want to see which side has more of the B's on it. And then I want to just take away the same number of B's from both sides so that there's only B's left on one side. I can visualize this. and have 10 B's, 9, 10, and I can have 2 A's minus 4 being equal to 3 B's and an A. So to simplify it, let's take an A off of both sides, and let's take those 3 B's off of this side, 3 B's off of this side. That leaves me with 1, 2, 3, 4, 5, 6, 7 B's and an A minus 4, and there's nothing left on that side. My goal, though, is to have B all by itself. So let's start moving these things over to the other side by adding 4 and by taking away A. That leaves me with 7B equal to 4 minus A. But I just want B, so to undo that multiplication, I'm going to do division, and there we go. This will cancel out, and I'll have something like this. And it looks kind of like sloppy and messy, but then we stop. Because if we're given what A is, we can figure out what B is. Okay? If we figure out that A ends up being negative 18, or no, let's say negative 10, then B is 2. But I'm solving one term in terms of one of the other terms there. So there we go. We're finished. There's no more math to be done. We solved one thing in terms of the other one. Algebraically, they can be a little clunky until we find out what these two things are. That really helps if it's put into maybe a word equation, a word problem. The algebra, it just seems kind of boring and like, why am I doing this? But really, it's going to come down to how are you going to use this in the sciences. So let's talk about a real one here. Let's talk about conversion between degrees Celsius and degrees Fahrenheit. When I went to England, everything over there, they were telling me what the temperature was, but it was all in Celsius. So they said, oh, it's going to be pretty nice today. It's going to be 17 degrees. And I'm like, it's going to be nice, huh? I'm doing the conversion. I'm like, oh, it's going to be in the 60s. Or if they say it's going to be a scorcher today, it's going to be 25. I'm like, that's like 70-something degrees. And I tell them where I came from, it used to get up into the 30s all the time. And sometimes it got to be 40 degrees. And they're like, oh, that is horrible. I'm like, yeah, I know. I was doing the converting in my head. What if I know right now what it is in Celsius, but I want to figure out what that would be in Fahrenheit? What if I'm European? And I'm thinking, what if I go to visit Florida? What temperature is it going to be there in terms of what I know? Well, I want to solve this in terms of F. I want FB to equal something where I can plug in C. So I got to undo this equation right here. How am I going to do that? I got distributive property here. I can do that. Degrees Celsius. I'm going to get rid of the degree thing. It might get confusing. But I got 5/9 F and 5/9 of 32. 5/9 F and 5/9 of 32. So let's get the calculator going here. Oh, I'll do it on the other calculator. I'm doing it the clunky way. Oh, we'll keep going with it anyway. Okay, this gives us 5/9 F, and I'm just going to leave it like this, 169 equals C. I want to solve for the F though, so I got to move this over. C equals negative 169, or no, C minus equals 5/9 F. I want just F, so I multiply both sides by 9/5. This leaves me with that F equals, and then you get something that's a little bit more familiar to you. What's 160 divided by 5? That's 32. Yeah. I'll get 9/5 C minus 32. Now, I did it kind of clunky, like once I got here, I should have just multiplied both sides by 9/5 right here. And got 9/5 C equals no more parentheses. And then subtract 32. I get the same thing, 9/5 C minus 32. These two rules or functions are called inverses of each other. Inverse functions. One undoes the other one. If I put them together, I get that what's called the identity function, x equals x. But they're going one direction or going back the other direction. F in terms of C. We started with C in terms of F. Another place where this comes in handy is in the realm of geometry. Okay, the realm of geometry. Lots and lots of conversions work this way that you're going to deal with from one thing to another, but in geometry as well. Remember how circumference is defined? Pi times diameter, or pi times twice the radius. What if I know the circumference already of an object and I want to figure out what the radius is? The radius is actually pretty hard to measure because you have to get it perfectly straight across, where circumference, maybe you could take some string and roll it around or something like that. Whatever the case may be, what if you wanted to do this r equals in terms of C? Okay? How would you solve this problem? Well, we want to isolate the r. This one's going to have to be in r equals and everything over there. So if it's multiplied by 2 and pi, we would want to divide by 2 and pi. So we could have circumference divided by 2 pi is our radius. And then they might give you the circumference, you plug it in, and then you just solve in whatever the units are. There are a lot of those in geometry. Another one that happens a lot, common in algebra, is distance equals rate times time problems. Think about that. You're driving down the road. It tells you what the distance is to the next town. You look down at your speedometer, you see what your speed is or your rate, and then I'm always thinking, going to Oregon, well, how much time is that going to take us until we pull up in front of Grandma and Grandpa's house? So sometimes you don't know the rate and time. Time's going to happen depending on the other things, so maybe you don't want to solve it that way. Maybe you want to solve this for time, and the way you're going to do that is dividing by rate. Time would equal whatever the distances I have to go at whatever average speed that I can maintain. That'll tell me how long it's going to take to get there. Okay? Or I've got 50 miles to go. I only have 20 minutes to get there. How fast do I need to be going in order to go there? You want to solve for r in terms of distance and time. So pay attention to what they want you to solve for. Very important. I like to circle that. And then you're just going to use your same rules of algebraic manipulation, adding or subtracting from both sides, dividing or multiplying both sides by the same thing, in order to end up with just one variable on one side and everything else on the other. And then you can express one thing in terms of something else, solving literal equations.